Hi all, so welcome to the today's tutorial. So previously what we have done in Avaka, we have added the arrow component with the sockets, we have added the spring arm, and we've added the camera. So today our task will be like right now, if you will drag and drop the car and perform the simulation, it will just get down, so no force is there. So we will look into it. So previously we have attached the wheel, yes, but what we need to do, like, let me take out this picture. I have taken this picture from the internet just to show you like how the calculation will work. So first, the wheel is attached to the axle, and axle will be attached somewhat right here, so like in the chassis of the car, right? So for the same, what we need to do, we have to shift these sockets up up somewhere here, right, in the top. So what we will do, I think, I'm not for sure, like, but it will be around 86 or somewhat around 90, like, if you want to be precise you can be, but it will be like 87. So for all of them I will set 87 just to have the consistency. 87. Press save and let's check if everything is working fine or not. Yes, okay, they're good. Cool. So this is the first task, and for the second, let's see how we will do the calculation. So we have to put force, like how much force we have to put, so like our car will be in air, so we will do that. So let's see how the things and how the variables which we will use. First, let's see what is the rest length first. Second is spring travel, sorry, and next is wheel radius. So these three variables are there. So let me reiterate it again. First is rest length, spring travel, and the max length. So rest length is, give it a second, yeah. So the rest length is the axle length which will be attached, yeah, right? So let's imagine here the spring length is the length of the spring. Let's imagine this is the spring. So spring, like, let's imagine this is 10 and the rest length is 30. I'm just having an example here. So the, let's imagine the tire is here, like in the starting, so it can become down also 10, and it can become up also. So like the maximum it can go, it will be like 40, and minimum it will be like 20, right? So this will be the range, like, so this is the travel value. So we are now familiar with the rest length, we are familiar with the spring travel. So when we will add these two, it will be the max length. And what will be the minimum length? Like, this is the max length till here. The minimum will be like when we will minus this spring length from the rest length. So you got the idea of max length and the min length. So this is clear. Next thing is wheel radius. So if someone asks, like, when we will check, like, we will use a hit trace, we will use a hit trace of length, max length plus my wheel radius. So we will check like if we are hitting some object or not. So this is our first task which we will do it today. So I think you have got the idea. Yeah, okay, let's dive into the code then. So first thing is, if, okay, we will come to this part later, like in today's tutorial only, but let's continue. So first, open the vehicle base. Let me open my IDE. Okay, cool. Let me close this. Yeah. So just to have things in consistency, so first we will declare the variables. So these will be the exposed variables. So first is rest length, if I'm not correct, rest length. So we will set something, but So I have already took the values, so it is 50. You can also change the values. So I'm just keeping the values like this. I have tested like my project with these values. So one unreal value is equals to the 1 centimeter. So it will be 50 centimeter. So this is the realistic length. Next, okay, first I have to define the u property just to expose this variable so we can edit it. And I also want blueprint read only, just in case I'm just keeping this. I want few more variables, so I will copy paste it. So first was the rest length, next was spring travel length, and I will keep it 10. We can also keep it 20, like just to get the jiggle effect. Next is the let's say wheel radius, and it was 34 if I'm not wrong. Okay, what else? We also do want spring constant, but we will talk about that later. But let's start our task with these variables. So inside the CPP, first I have 4 arrow components which we have created in our previous tutorial. We have to initialize, like we need a container just to hold them. So what I will do, I will go to private. I think I haven't defined that private, so it will be the T array of type it is the type of U arrow component. It will be the pointer the arrow component wheel arrow component holder arrow component holder. Okay, so this I will initialize once my components are initialized. We can also do that in begin play, but just to like I just want to call this function after everything is initialized. That's it. So what I will do, or let me do it in begin play, no issue. So we what I usually prefer, like, to do all the physics initialization in the post initialize component, because physics thing needs G engine, so that is why. Or else, like, all the initialization we can do in the construction, but if you want it like after we have we are in the game, then it will be the begin play. So like what I will do, I will initialize with the arrow component front right, arrow component front left, arrow component rear left, arrow component rear right. So we have initialized it. Okay, next what we need to do, we need to initialize the min and max. So okay, it will be the they will be the private variable. So what I will do, float min length, what should be min length equals min length float max length. Okay, what else? Let's initialize them. Min length min length will be equals okay, sorry, so min length will be equals to rest length minus spring length, spring travel, oh I think spring travel length, yeah. Next is max length is equals to rest length plus spring travel length. Okay, so I think we are good to go. We have initialized the arrow component too. Okay, so next I want my function to run in the tick, but I also want index, like where I do want to retrace to start, because I have 4 positions to go, like right, left, like in front and back, right? So I will create a function in the private only. What I usually do, I always keep my variables up and functions at the down. So yeah, void update vehicle force integer wheel arrow index comma float delta time. Alt enter. It's just a shortcut which I usually use, but okay. Okay. I don't know, like sometimes it create the inline, but sometimes it do the perfect task. So you can also like right click and generate the function in the Visual Studio. It does also have that shortcut which you can use, or you can just type it here. Okay, so what I will do, because we have 4 wheel, so for integer I, just to keep it simple, I less than it will be like 4 I plus plus, just the basic array. And update vehicle force, it will be the index, and I will pass the delta time. That's it. Shift 6, let me wheel arrow index. Yeah, okay, cool. So what it will do, it will iterate like from 0 to 3, and we will check like in which index we have to apply the force, then we will do the task. Okay, so first thing first, I will check if I have the valid arrow component or not. So let's check it. If I have holder wheel holder dot is valid index wheel arrow index, so if it is invalid I will just return. So from here I will start my main thing. What I will do, I will take the reference of arrow which I will use. So arrow is equals to so I will take the arrow from my holder, so wheel arrow holder, the wheel arrow index. So okay, I have the arrow. So now I just want my hit line trace, like here let's imagine I have the starting of our vehicle. So here I will just put the line trace of distance which we have calculated, like max length plus may wheel radius. So at this length we will put the line trace in downwards direction, so that we will do. So just to put the line trace on, we need the f hit result. So out hit, and we want start and end, so f vector start trace location is equals to it will be the arrow location, get component location, yes. Next is f vector and trace location is equals to, so this is the perfect part. So we have calculated, right, like what distance do we want to like retrace on. So it will be like arrow dot get forward vector into the distance which we want to do plus में start trace lock. So the thing is, the forward vector is always of a unit length. So what we are doing, let's imagine, like, see, let's imagine this is the world origin and our vehicle is starting here, right? Correct. So first thing, the forward vector is of unit length, so it will be somewhat like here and it will be very small length. When we are multiplying with the max length plus my radius, so it will become the length like something like this. But our vehicle is here and it is relative to the world origin, so we have to add to start trace location. Like we have kept our arrow, so when we will add, it will shift this vector from here to here. I think you have got the idea. So let me type that. So max length plus wheel radius. Okay, so we have got the start trace location and the end trace location. So let's start with the line trace signal. So get world line trace single by channel out hit comma. Next, what do we need? We need the start location, so we have it, start trace and trace comma. What do we need? We need trace channel. Okay, we will use camera only, so I think ECC camera will do the task. Yeah. Next is, okay, this is actually important. We want custom F collision query params. So what I will do, I will create a variable. Let me go to my private, so it is the type of F collision query param. Okay, let me have it F collision query param. Okay, it will be like line trace collision query. Okay, let me define it in the private only. Let me have some idea. Okay, and what was the name of line? Okay, let me capitalize the L word. I always keep the members variable with capital starting, and I always keep local variable as small starting. Let me change it to arrow. I will change the name, just give me a second. So line trace collision query. Next is I think, and I will use default one, so F collision response params. Okay, cool. So now the question is why I have created the custom one. So in here, like in the begin play, I do want to add debug line trace. So line trace collision query dot trace tag. So I will create a trace tag. I will just explain what I'm doing here. So let me, so line trace collision query dot debug query true, and I also want to ignore my actor, add ignore actor, and it will be this. Yes. Okay, for the trace I will create a constant f name trace tag. Let me give it some name like my trace tag, and I will assign this trace tag here. So the thing is, if you won't give the debug query as true and you won't pass the trace tag, the custom one, it won't show you any debug line. In the blueprint version, you do have a check where you can turn it to true, and it will give you the default lines, and it is very good to visualize. but in like C++, this is the perfect method which I usually use. You can also like draw the debug line. It is also a method, but I usually prefer this way. Okay, so as soon as I am hit, so what I will do, if out hit is valid blocking hit, so I'm just checking like if it is a valid hit or not. If yes, so we will do something. Next is now, okay, now the second part. So we have corrected the first part, like you got all the calculations done, right? So now for the second part, like what calculations do we need to do? Like by default, like imagine this was our drawing, right? So okay, I can rub it. Yes, okay, let me rub it then. Okay, cool. Yes, so this is the rest length. Let's imagine the spring was extended till here, so your actual location of the wheel was somewhat right here, but in the next frame it hits something, so it will go up, right? So it will compress this spring, and our new location will be somewhat like here. I'm just imagining the things, okay? So what is happening, we have to like keep the track of previous length and the current length, so we can check if it is the compression, or else was it like expanding, or was it compressing. Yeah, so for these two we will just keep track, and we will apply the force accordingly. So we need to do two things. First, I will get the reference of previous length which was there. Next, what is the current length which I have hit. Okay, think you got the idea. So what we will do, we are applying the hit here till here, and after the hitting we will minus the radius of the wheel, so we can actually get how much the wheel is like how much the spring is expanding, or is it expanding or compressing. So this is what we need to do. So this is doing the same, like length of the spring is the distance between recast origin and the vehicle hit minus the radius, wheel radius. So we'll use the same. I think you have got the idea, so I'm just closing it down. Okay, okay, so let me create a variable of spring length. Let me do it here. So it will be a float of type is sorry, it will be like spring length, and I will initialize it here only. Will be like 0 comma 0 comma 0 comma 0. Okay, so what I will do first, I will like save like what was the previous length, so that I will do it here. So if you hit I think it will be good. So previous float previous spring length is equals to spring length, and what was the stand wheel arrow index. Yes, so I have got the previous one, and here I will get the spring length now. Float current spring length is equals to out hit dot distance. So it will actually calculate the distance, like from here, let's imagine from here to here. I have started the trace here. Let's imagine the trace was still here, but it hit something, so this distance I will get it from here. Okay, next is so it was minus radius, so I have got the spring actual length. So next I will use the clamp and I will save it in spring length. Sorry, spring length, the arrow index, will arrow index is equals to u kismet math library f clamp. Okay, so the value is current spring length comma main length comma max length. Okay, so how you will how, like, if you are shifting from blueprint to C++, how do you know that it will be the ukismet math library, just to have the clamp? So what you can actually do, just write the clamp keyword. Let's imagine that we are trying for the float. Just hover over that node, and in the target you can see it is Kismet math library. So if you will type it on the Google Unreal CPP, it will give you the actual name, and it will also give you the header file, like, which you can also use. So okay, so I have got the spring length. Next, what I will check, like, whether it was the, like, I will get the difference, like, from the previous spring length and the current spring length. So float spring difference is equals to rest length minus spring length index. Okay, cool. So this is done, but the thing is, so like, the more difference will be, like, the more it is compressing or the more it is expanding. So these two will happen. So and we will minus this spring length. Just make sure, like, we are taking the difference from the rest length. Okay, so rest length will always remains constant. Like, this was the rest length, and this the spring. So this will always remain constant, and we will take the difference from this only. Okay, the rest length. Okay, so if what I will do, so it will be the spring force, and I will, like, multiply it with the spring constant, spring force constant. Let me name it clearly. So, like, every spring in the physical world does have some constant value. So I will create the field. So I'm just creating the variable called float spring force constant. I use a shortcut because I'm using RIDA. What you can actually do, you can go in the public and let me define the u property also. And for the spring force constant, I was using 500 value. So let me initialize it 500, but we can, just for testing in the blueprint, we can actually change it because we are using edit anywhere, so it will allow us to to check the things. Okay, so get back. So we have got the spring force. Now we just have to apply the spring force in our code. Okay, so next thing is, if we are not hitting anything, so what will happen? Like, spring length vehicle arrow index will be equal to the max length, obviously, because I'm not hitting. So maximum wheel can like go like rest length plus may spring arm, so it will be the max length. So spring length will be like this. So now we will calculate the actual force. So F vector is called like upward force. So it will be the upward force. So get actor up vector into the actual force which we don't want to apply. So it will be the spring force. Now we have to apply this force at some location. So let me check what was our mesh name. It was the body mesh component, so body mesh component, add force at location. So how much force do you want to apply? It is like upward force, comma, uh, what is the location? So location, how we will get, we have the arrow, so arrow dot get component location, and this is it. Okay, now our coding is good, but just for the naming sake, I don't like the name, like it should not be the arrow. So the naming should be right click refactor rename, like arrow wheel arrow component. Okay, let's check if everything is fine or not. So let me compile. Control Shift B is the shortcut just to compile the code faster. Okay, it's done. Let me debug the code. What debug will do, it will open the new instance. So let me close the previous one. I don't want to save anything, just click don't save, escape restore. So it's up. Let me check if it is working fine or not. Oh, it is not. So let me okay, do you want me to increase okay, we have the expose variables as we wanted. Let me check if we are doing everything good. Everything seems correct. Let me crank up the value to 10,000. I'm just spicing up the things. Okay. Okay, so the first issue is we are passing the delta, but it will be delta time. You must have seen this, like, but I haven't. But okay, let's see. Let's see if it is working fine or not. It is still the same. Okay. Okay, so I got the problem. So the issue was with these values. So what I did, I just multiplied all the values like rex length, spring length, and wheel length into 50. So because previously it was too small, so let's check if they are working fine or not. It is somewhat working, but it is not that close. See, first let's check the collision which we do have in our car. Let's check their body mesh. Okay, show simple collision. Okay, so let me remove it and put simple box collision. Okay, I'm ignoring the actor, so it should do the task. I'm not doing it precisely, but still, let's see. Okay, let me change the spring constant to 5000. Let me check. Okay. Okay, but our like vehicle is doing something. This is a good sign, but let me check it again. Okay. Okay, sorry, but it's already 34, so I guess we can continue in the next tutorial. So in the meantime, you can check like what is the issue here. I this was just for testing, so I'm just re-adding that. So Okay, let's see you in the next tutorial. Thank you and have a nice day. Thank you. Take care.